Okay, good morning. This is AP Computer Science A. This is Tuesday, April 14th. Hopefully you're all having a fantastic start to your morning as we just spent the last 10 minutes, talking about some gaming. Nothing wrong with that. We're all nerds united together and it's fantastic. So, in any case, what I would like to do with you guys today is I would first like to go over the homework assignment on methods and objects and writing the code for that. I'm going to show you that in just a minute right here. Should be able to see it's the methods and objects refresher homework. I'd like to just go over this, show you how I did it. Again, my solution, just like last time, my solution is not the only solution. In fact, it's far from the only solution. But I just want to show you the way that I approached it. I'm realizing now, just as I'm talking, that I don't believe I uploaded the solutions document for the arrays homework. So I'll make sure I do that. I have it. I just got to put it on Classroom. So I'll make sure I throw that on Classroom for you at the end of class today, as well as my solutions document for this one, the methods and objects homework. Okay. What we're going to do after we go over the homework is I did provide for you 2 free response questions on Google Classroom. I think these are excellent examples of free response questions that you may see on the AP Computer Science A exam. Again, you know all the modifications to the exam this year. I've sent you a ton of information as far as that's concerned. So I think these 2, coincidentally, they were back-to-back on a practice exam, and I think they actually encapsulate some great concepts that you should expect to see on the AP Computer Science A exam. So there's that going for you. All right. There's 2 on this document. I am going to go over the first one with you, and I'm going to ask you to do the second one for homework for next time. All right. So that's our plan of attack for today. A couple things I want to mention first is, again, hopefully everybody had a great long weekend, great Easter weekend, Passover weekend, or if you don't celebrate either, then hopefully you just enjoyed your 4 days. We do have a couple of great resources to prepare for the AP Computer Science A exam. I did set up a Code HS class for everybody. I saw that only 2 people joined it so far, which I'm not upset about. It's nothing personal, but I'm just saying it's a fantastic and free resource. It's not normally free, but due to the current situations, it is currently free resource for you to prepare for the AP Computer Science A exam. I equate it very much to Khan Academy. I think it contains a lot of fantastic, useful exercises and examples on all of the concepts that you should be expected to know for this year. Just a little heads up quickly is that, again, the AP Computer Science A exam is focused on the first topic being arrays and array lists, the second topic being methods and objects. Okay, so if you get into that Code HS class and you start scrolling down, you'll see stuff on 2D arrays, you'll see stuff on inheritance, you'll see stuff on recursion. All excellent stuff, but not the focus of this year's AP Computer Science A exam. What I actually decided, and I'll share this information with you now, is I did decide this year to show you all of the extra stuff that we didn't get to for AP Computer Science A, namely the searching and sorting algorithms, as well as maybe just finish up our discussion on inheritance quickly. I want to show those to you after the AP Computer Science A exam date, because I think it would be I would feel bad. It would be remiss of me not to do that as far as like preparing you for what you're going to see next year if you take a computer science course in college. You will definitely talk about those things, so it will be only to your benefit to have a little bit of a head start on exploring those topics. So that's why after the AP Computer Science A exam, I do want to revisit those topics and make sure I talk about them with you. Normally I do like sort of a free choice idea where it's like, hey, what idea in computer science do you want to learn about? And the class tells me something and I research it and come up with a lesson for you. But I think we're going to do this year because it's probably better overall that you do understand those aspects of the AP Computer Science A curriculum. All right, so hopefully that's going to have us get some good structure after the AP exam. All right. Prior to the AP exam, however, these class periods are really just going to be used for preparing for that AP Computer Science A exam. Again, you have 2 big topics on there. Your first question is on arrays and array lists, and your second question is on methods and objects. All right, so you should be comfortable with all of those things to approach those free response questions. But anyway, like I said today, my goal is to be able to explain to you my problem-solving process for how I approach one of these free response questions. This number 3, I didn't even do it yet. I read it, but I didn't actually do it. And the reason I didn't do it ahead of time is because I really wanted to show you my process as to how I think and think out loud with you to hopefully explain the logic of how I approach these problems. So that was my intent. We'll see how successful that is momentarily. Anyway, just to quickly go over, first of all, does anybody have a question on anything I just said? Questions? No questions? Feeling good? Feeling fine? All right. If you do have a question, feel free to interrupt. So just to quickly go over the homework, this was not meant to be overly difficult. It was just meant to be a little bit of exposure, again, on methods and objects to get you back up to speed on that. The big thing that I wanted you to take away from this too was also a lot of the notation, because all of this notation is exactly what you're going to see on the AP Computer Science A exam. You're going to see preconditions, you're going to see postconditions. That's what we started talking about last class and the class before. But just to get more and more exposure as to what that's actually going to look like when you see it printed on the screen on the exam, it's going to have this sort of syntax to it, where you're going to see what's true before this method executes and what should be true after this method executes. That's precondition and postcondition. So starting with the two-argument constructor, the two-argument constructor was very, very simple. It was just setting degrees equal to temp degrees and scale equal to temp scale. Remember that this is the order that it goes in. You're setting degrees to be equal to the parameter that's provided in temp degrees. You're setting scale to be equal to the parameter that's provided in temp scale. Notice that because there's different names, because this is not called degrees, you don't have to use the keyword this dot. If you did use the keyword this dot, it's not wrong. Certainly no problem with that, but it's not necessary. It's only necessary if you want to name everything the same. Then you have to say this dot degrees equals degrees. Okay? So shouldn't be any questions on that constructor. Very, very straightforward thing. This one is just a mutator method to convert the temperature to 1 in degrees Fahrenheit. One really interesting thing about this program, I thought, is that it specifically returns a temperature object. Nothing wrong with that. We can return a temperature object if we want, just like we can return an int double boolean or not return anything if it's void. We can return a temperature object, no problem. So we just, the way I did it is I said double degrees Fahrenheit equals, and I did the whole conversion thing here. One quick key thing to notice is I did type out 9.0 divided by 5.0 because that will convert everything to doubles instead of integers. If you just left it as 9 divided by 5, well, according to our integer division, 9 divided by 5 is going to come out to be 1.8, but the 0.8 is going to get dropped because it's an integer, right? So you could type, in order to circumvent that, 9.0 divided by 5.0. That 0.0 will have that recognized as a double. The other thing that you could do is you could cast one of these things to a double. You could do this if you wanted to. So you can cast 9 to a double and then divide it by 5 so everything stays as doubles. Just make sure when you do that, you cannot do this, like cast the whole division of 9/5 to a double, because the division already has occurred. The 9 divided by 5 already occurs. It comes out to be 1, and then it converts 1 to a double, and it's like, oh, 1.0. Okay, I can do that. But it's too late at that point. So what I like to do is just do 9.0 divided by 5.0. If you want to cast it to a double, that's fine too, however you approach it. But then all I do is I say temperature T equals new temperature. Keep in mind, to create a temperature, we need the temperature in degrees and the scale. Since we're converting to Fahrenheit, it makes sense if the scale is Fahrenheit. And we're just going to use this parameter of degrees Fahrenheit and then just return T. Okay? Instead of actually doing this whole line, you could have actually just said return new temperature degrees F and then F here, because that will actually, instead of just temporarily storing it in this value called T, it'll just directly return that temperature object if you wanted to. And then you could have gotten rid of this return T line, but no problem with just doing it one step at a time. That's why you could technically do this whole thing in one line. You could say like return new temperature and then do this whole calculation to come up with degrees F and then put F, but a little overly complicated, but possible. All right, next we have to Celsius. To Celsius is very similar, does the same formula just in reverse and the same general structure. So hopefully no questions on that. Again, keep in mind the precondition and postcondition. If you notice, I didn't have to check in this method to make sure that we were in degrees Celsius prior to converting my temperature, because the precondition is that degrees is a valid temperature measured in Celsius. So you know that, hey, whatever I'm working with here is already going to be in Celsius prior to this method being executed. And that's a really important thing. If this precondition were not here, one thing I'd have to do is I'd probably have to say if my scale is Celsius, then actually go through the conversion. Otherwise, just return the temperature because that means it's already in Fahrenheit. But since this precondition is here, that check is not necessary. Same deal with down here. Okay? Question about that? Hopefully none? We're good? Feeling good? Feeling happy? All right, fantastic. Next, we had just raise and lower. They both work very, very similarly. What you want to do is, again, return a temperature object by raising the current temperature by that amount. We can just say temperature T equals new temperature. We raise the degrees by that amount, and we keep the scale the same. You're not going to convert all of a sudden Fahrenheit to Celsius or anything like that. You're just raising the temperature by amount degrees, whatever that amount is. Okay? And the same thing with lower. You're just going to create a new temperature object with your degrees modified by that amount and the scale being the same, and you're going to return it. Okay? And then lastly, a little fancy print line here. You could have printed it out in whatever way you wanted to, as long as it satisfied displaying the temperature and scale. I just said current temperature is the temperature and then degrees scale. So it would be degrees Fahrenheit or whatever. Okay? Any question about any of these problems? This should have been a pretty straightforward idea, but hopefully a good, way to get back into doing free response questions for these topics. All right. So now directing our attention to this actual homework assignment. One thing I want to show you again is my thought process for how I approach these free response questions. You do have a limited amount of time to deal with the free response questions. So as always, whenever you're taking an assessment, I always recommend doing what you know how to do first and what you don't know how to do second. Just like if you're taking the SAT, if you read a problem and you're like, shoot, I really don't know how to solve that, don't spend 5 minutes thinking on it, move on to do the other stuff that you know how to do, and then go back to do that once you have extra time. Anyway, what this says is, in this question, you will implement 2 methods for a class tournament that keeps track of players who have registered for a tournament. The tournament class uses the player class shown below. A player has a name and a player number specified when a player is constructed. So very simple. We just have a player with 2 argument constructor, a name and a number, and then we have get player number. All right. What you need to know is exactly that. You don't need to know how these things work, hence why the implementation not shown comment is there. You just need to know that they work. Get player number will get the player's number, and this constructor will set these things equal to whatever variables is necessary. All right? You don't need to know the implementation of these to solve the problem. You just need to know that it works. Okay. Same thing here. An incomplete declaration for the tournament class is shown. There are 100 available slots for players in the tournament, and players are numbered 0 through 99. So their player number corresponds with their position in the array. That actually took me 2 read-throughs to actually make that connection in my mind. But what solidified it for me was this statement right here when it said slots at index I dot get player number should be I. In other words, it's whatever index they're stored at, that is their player number. So that's something interesting to keep in mind. So anyway, we start with this array of players called slots, and it says it's the list of slots in the tournament. Each element corresponds to a slot. If slots at index I is null, meaning there is nothing there, the slot is not yet taken. Otherwise, it contains a reference to a player. For example, slots at index I dot get player number returns I, like I just said. We also have this array list. By the way, you may notice that this thing is called just a regular old list. A list is a more general type of array list. For all intents and purposes, an array list and a regular old list are the same thing. I know there are differences. Actually, a list is the parent class of array list if you want to talk about inheritance. But I really wasn't able to find any significant differences between array list and just regular old list. They use the same syntax, where it's the .get, .set, .remove. They use all the same formatting. They have the same structure. I really wasn't able to notice much different. So if you see just a list on the AP exam, which I don't think you should because it did specifically say array list, but know that it's just really the same as an array list. Okay, we have this thing called a waiting list, which just keeps track of all the people waiting. All right. We also have a couple methods in this tournament thing, one of which we're going to do in part A and the other we're going to do in part B. It starts by saying request slot is what we're going to do in part A. I think these little descriptions above the methods are like this is what you need to do. In fact, this is really your instructions. Yes, everything else is giving you all the framework and the context for how this problem exists and why this problem exists and all that stuff. But I think this is really the key. For part A, we're going to be implementing this method called request slot. It passes in a player name. Here's what the method does. It says if there are any empty slots, so slots with no player, meaning that the slot is null, assign the player with the specified player name to an empty slot. So we're just going to throw the player in there. Create and return the new player. We can do that, no problem. Okay, so we're going to create a player, we're going to put it at that spot in the array, and we're also going to return it. If there are no available slots, add the player's name to the end of the waiting list and return null. Well, that's easy as well. So we can just say if the whole array is full of players, then we can just go ahead and add them to the array list. All right. And then just a couple little notes here. Player name is the name of the person requesting a slot. When you see this at player name, that means it's describing what player name does. And then at return means what are we returning? We're returning the new player. Okay, so before I even go on to the second method, I'm just going to stick with that first method. Again, it gives you a whole, it just restates all of what we just said right here. Again, you have more instructions here. I think the instructions are super key because it literally outlines for you in most cases what you need to do. It says write the tournament method request slot. It tries to reserve a slot. If there are available slots, one of them is assigned and a newly created player is returned. If there's no available slots, it adds to the end of the waiting list and null is returned. So what I'm going to do is I just quickly typed up over here some stuff. What I'm going to do is exactly that. I'm going to start typing my method here for request a slot. So going back to my instructions, again, I think this block of instructions is the most important. If there are empty slots, assign the player with a specified name to an empty slot. So we can do that really fast. We can say if there are empty slots. Well, let's search through the array and see if we find any spots that are null. So to search through the array, I'm going to say for and I is 0. I is less than slots.length because that's the name of the array up here. And I++. All right, so first of all, trying to find if there are any empty slots. So I'm going to say if slots at index I is null. So we can say is null. Right, meaning that there is nothing actually stored there. It's just set to null. Null, again, means sort of empty for an object, right? It means there's just an empty position there. We can say if slots at index I equals null, then you want to go ahead and insert the player object at that position. So you can say player, P equals new player. We can have their player name. And their player number will be their position in the array. So their player number is I because that's the spot in the array. Again, the thing that made that click for me was this line right here. For example, slots at index I.get player number returns I, meaning their player number is their position in the array. Okay, so we have that now. We can then say slots at index I is set to P, so we could just store P right at slots at index I, and then we can return P. Yep, so that should work out just fine, where I notice I created a player, we put them at that spot in the list, and we found all that stuff. Okay. Now, if we manage to get through the loop and that never happened, remember, return is an immediate end for a method. So when you say return P, that means your method's done. If we got through that whole loop, though, and we found that, hey, that never actually happened, well, then we need to go ahead and add them to the waiting list. Okay? I'm curious if it says anything about their player number for the waiting list. Return null, add a new player. I don't think it does. So I think we can just go ahead and put their, oh, sorry, the waiting list is a list of strings. So we actually don't need to create the player object. It's just a list of strings. So we can just go ahead and add their name to the list. So I'm just going to say, what's it called? Waiting list right here. Waiting list dot add player name. There it is. And the last thing it says is return null. Bam. So certainly not the only solution again, but I would say that's definitely a valid solution for the first method. Does anybody have a question as to how I typed that? Again, you're literally going off of, and this is the number one advice I can give for you for free response questions, literally going off of the directions. Okay? Part B asked us to do this cancel and reassign slot. So here's what it asks us to do. Release the slot for player P, thus removing that player from the tournament. So if you notice, it's going to pass in a player object called P. Okay? So in order to locate that player, what I can do a couple things. Number one, I can do the dot equals operator. I could also just search to say, hey, does this player name match that name and their number match that number? I think that's actually a really good way to do it. So that's pretty much what we're going to do. If there are any names in the waiting list, remove the first name and create a player in the cancel. Actually, you might not even need to do that. I'm thinking about it now. Since their player number just refers to their spot in the array, couldn't you just say remove the person at that position? I think that's actually a better idea. So we're going to do that. If there are any names in the waiting list, remove the first name. So that's going to be the name at index 0. And create a player in the canceled slot for this person. Return the new player. If waiting list is empty, mark the spot specified by P as empty. Okay, so all I think I'd have to do is I'd have to say, oh, go into the wrong document. Release the slot for player P. Remove the player from the tournament. So we're going to do exactly that. So remember, the player number of player P actually refers to their position in the array. So what I'm going to do right away is I'm just going to say slots at index P dot get player number. I believe that's the name of the method up here. Dot get player number. Yep, there it is right there. I want to just set that spot equal to null, right? That means we just remove that person from the specific array list. So we accomplish that. If there are any names in the waiting list, remove the first name and create a player in the cancel slot for that person. So if there are any names in the array list, I can say if array list is called, what's it called? Waiting list. If waiting list dot size is greater than 0, meaning that there are people waiting for the tournament, I can say waiting list dot remove. Oh, sorry. I can say slots at index P dot get player number is now equal to new player, because we want to create a new player object now. And I can create that new player to be the name, right? So I need to say, let's see. Oh, actually, you know what? Let me do this in several lines. Let me not do it all in one line. You can certainly do it all in one line, but let me just do it in separate lines. So the first thing I want to do is I'll extract the information from that array list. So to extract the information from the array list, I'm going to say player. Can't call it P. I'll call it rats. I'll call it play equals new player. And we want to go ahead and grab the information from the array list. So I can say waiting list dot get at index 0, and we want to get that player name. So that's going to be their name, because remember that array list is a list of strings, correct? I keep thinking that the array list is a list of players, and it's not. The array list is just a list of names, and their actual name gets assigned, or their actual number gets assigned when they actually get put into the list. So we're going to create a new player with that name at the first position in the array list, and the number, I'm just going to use the same player number as P, because we just removed that player number from the list. So I'm going to say P.get player number. Okay, so we've now created this new player called play. I'm then going to insert that player into the array at this spot. So instead of now saying that slots is equal to null, I'm going to say slots at this index is now equal to play, because that's what we called our player. Not the best name, but hey, you know, it is what it is. And then I want to make sure I remove that person from the array list. So now I'm just going to say waiting list dot remove index 0. Okay. So I believe what that did, and anyone can feel free to chime in if I did make a mistake, but what that should do is it should say, if there's people waiting, I'm going to make a new player object from the person in the first spot of the list, and I'm going to use the player number that was provided to me because that's the position I need to insert them in. I'm going to put them there, and then I'm going to remove them from the waiting list. Hopefully that makes sense, yes? Let's see what else this method has to do. If there are names, remove the first name, create a player in the cancel spot for this person, return the new player. So let's do that. So return player. Return the new player. So I want to return play. Okay, there we go. We return the new player. It then says, where'd we go? It then says, let's see. If waiting list is empty, mark the spot specified by P as empty and return null. So we could put an else here. You know, actually wouldn't need to put an else because if this if statement doesn't trigger, then therefore it would just continue doing the rest of the code. If the if statement does trigger because it hits return, that means it would never actually continue on here. So you could put an else or you could not put an else. It's up to you. But saying now if the list is actually empty, mark the spot specified by P as empty and return null. So mark the spot specified by P as empty. I believe we did that, right? We did that up here. Mark the spot specified by P as empty and return null. I think that's all we need, right? Because we marked the spot specified by P, the player, as empty. We already did that right up here. And then return null. Okay. I guess what you could do is instead of setting this equal to null right away, like removing them from the list right away, you could do that down here. But either way, I think that accomplishes that. Okay. Let me just make sure by rereading the directions here for part B. It says write the tournament method, cancel and reassign slot. It releases a previous player's slot. If waiting list for the tournament contains any names, the newly available slot is reassigned. We did that. The person's name is removed from the waiting list. We did that. The newly created player is returned. We did that. If waiting list is empty, the newly released spot is marked as empty, which we just did. And null is returned. So that should be totally fine. Does that make sense? Notice that it also tells you all of the information here, and it definitely will do this on the AP exam. It's very generous with saying, hey, you have all of this information to work from, so make sure you use it. You have the player object, you have this get player number, you have this array list, you have the method that you wrote previously for request slot, which I don't think you need, and then cancel and reassign slot. Does that make sense to everybody? I guess you could call upon, one thing I'm thinking of, you could call upon request slot, but I don't think that's actually necessary for this method. Actually, forget that. That's not necessary for this second method. Sometimes a lot of free response questions will say, hey, you have the ability to use the method from part A if you so desire. And it'll say, like, assume it works as intended regardless of what you wrote. So sometimes you will actually have to use a previous method. That's not the case here. This one's just brandy new. All right. But hopefully that makes sense how that works, yes? This, in my opinion, is a very typical free response question for something you could expect on methods and objects, okay? This uses some objects, it uses some methods, it uses some arrays, array lists. That's why I thought it was like a prime time example. It's like, ooh, this encapsulates pretty much everything that was going to be on the exam. Arrays, array lists, methods, and all that stuff, okay? I know we're just about out of time. One other thing I want to show you is I just want to very quickly talk to you about the problem that I'm asking you to do on your own. So the problem I'm asking you to do on your own is problem number 4. It says a chemical solution is said to be acidic if it has a pH integer value from 1 to 6 inclusive. The lower the pH, the more acidic the solution. Don't get overwhelmed and be like, oh, chemistry. It's not bad. Experiment has a large number of chemical solutions arranged in a line, so an array, and a mechanical arm that moves back and forth along the line, so that the acidity of each solution can be altered by adding various chemicals. So you can picture that. You have an array, you have some sort of pointer that's going through, and it can add different chemicals to each specific position. A chemical solution is specified by the solution interface below. Notice, we did not talk about interfaces in this class. And the reason we did not talk about interfaces is because it was actually cut from the AP Computer Science A exam for 2020, regardless of whether or not this whole situation was to occur with the pandemic we find ourselves in. It was removed from the exam. However, just treat these as normal classes. Interfaces are specific types of classes that serve very specific purposes, but you don't really need to know that. when you see interface, which you won't see on the AP exam, just treat it as a regular class. So in this regular class of an interface, and I'll talk to you about what interfaces are after the words, or after the fact, after the AP exam. I heard the chat pop up in a minute. I'll get to it. You have this int get pH, which returns an integer value from 1 to 14. 1 is very acidic, and it sets the pH to a new value. Okay? Keeps track of solutions in the mechanical arm. Again, it lists the mechanical arm as an interface, but you don't need to know that it's an interface. Just treat it like it's a regular old class. And say you have get current index, you have is facing right, and change direction. The important thing about these methods is you actually do not need to know how they work. You just need to know that they work. Okay? And that's a very important thing about the AP exam. A lot of times on free response questions, it'll be like, here's this object with methods that do these things. It is not necessary to know how those things get accomplished. You just need to know that if you call upon this method, this thing will occur. All right, and that's a very important thing. This get current index, you don't need to know how it actually figures that out. You just need to know, hey, if I call upon that method, that will tell me the index of where the mechanical arm is. You just need to know, hey, if I'm facing right, this method will return true. And hey, if I change direction, you don't need to know how that occurs. You can just know that, hey, that means that we're now going to be turning around. All right? Or moving forward, right? You don't need to know how it moves forward. You just need to know it does. Okay? You then have this thing called an experiment, which has a list of all your solutions. Actually, arranged it in an array list. It shows you, it pretty much tells you that this mechanical arm is going through the list and adding stuff. All right? What you have to do is, again, you have to reset the experiment. So the first method that you're going to have to write, don't get overwhelmed. The first method you're going to have to write, all it needs to do is makes the mechanical arm have an index of 0 and makes it facing right. So that's all this method has to do. That's it. You don't have to get bogged down in all the other chemistry stuff. Part B, all you have to do is find and return the index of the most acidic solution. So we talked about how to find the minimum in an array, right? Return the index at the location of the most acidic solution, or -1 if there are no acidic solutions. Keep in mind that an acidic solution is one that has a pH from 1 to 6. Okay? Post condition, the mechanical arm is facing right, so make sure it's facing right at the very end, and its current index is at the most acidic solution. So that's all you got to do for part B. So again, it's very easy, in my opinion, to get bogged down and overwhelmed by a lot of the context. Sorry, I know we're way over time, but you're thinking like chemistry and pH and oh my gosh, there's all these things and mechanics and all that. You don't need to know any of that. You just need to keep in mind this is your goal for part A, this is your goal for part B. Okay? Whew. Sorry, I know I went way over time, but I appreciate your attention and focus and willingness to stay a little extra. What do we have from the chat? Molly said, can we post a solution after we complete them? Absolutely. I'll be happy to post the solutions for you. Thank you so much for letting me know. I'll do that today. Post the solutions for the temperature one, the arrays one from last time, and I'll do the solutions out from this for next time. Yeah, no problem, Molly. No problem. Any other questions, comments, concerns for me? Sorry, I know we went way over time, so I appreciate you staying on for a little bit later today. No other questions? Hopefully that all made sense. Hopefully that gave you a good insight into sort of how to think about these types of problems. I think that was the goal of today's class and will be the goal of next class as well. So hopefully it was successful. All right, regardless, I don't want to take up any more of your time. I do hope you have a fantastic rest of your Tuesday, and I will see you on Thursday next we meet. All right, have a great day.
Have a good day, Mr. Giorgio.
See you later.
Have a great day.
Have a fantastic day.